In all my time teaching science, I've noticed a lot of students, they do struggle in terms of identifying a couple of key features in any scientific book, article, or spaces like websites. And one of the key things is how can they interpret visuals things. Like for example, we call them in science model, scientific model. And what does this mean? We're going to look at the following. First, we're going to look at the definition in this video. We're going to look at examples or types of models that are out there for students to recognize. And finally, how this can be applicable when they are in any setting. So, first is what is definition of a scientific model. Scientific model definition states that this is pretty much a way by which you can understand or you can describe. Some people can say that you can analyze and break down any form of scientific idea, and this here can come in 5 different ways with respect to the types. The first one is a spatial model, and spatial model pretty much looks at how all the parts of a system are arranged in a 3D space. And so 3D can be shown either on paper or you can actually go on a virtual space, VR or augmented reality. And the key takeaway here is that these parts that make up a system, they have a really decent representation in terms of the scale in real life. I say, for example, if you look at the part of the eye, the scale, the size of the retina, the different parts of the fluid, the muscles in there, and the shape as well of the eye is really a great representation when you look at it on a textbook. When you look at it in a virtual space, but in this case, in a virtual space, you can literally rotate it on the X, Y, and Z planes or axis, and you can also look at it in real life when you are doing operation and you're like, wow, this is pretty accurate in terms of the size, but maybe you can think about it relatively to what you have in the textbook, to real life. So that is something to take away when it comes to spatial model. Now, the second type of model that we're going to look at or students should be exposed to is mathematical, and this here looks at equations and how these equations can be shown, of course, either on the YX plane or you have your YXZ axis, a Cartesian plane, and the idea is that you're showing relationship between different properties, and these properties can be revealed in the form of lines or curves or in 3D forms. And so it's pretty cool to see how that can be generated. And most importantly, if you look at, for example, chemistry, you can look at, or even physics as well, the indirect relationship between pressure and volume, and this here can be plotted by, plotting the X and the Y axis, and you can have your 1 over V on one axis, and then you have your P on the other axis. And so by graphing, you can see how the points are generated and also lined up. So that is pretty much one of those applications that students can practice doing and can help them visualize what's going on where equations meet the equation or the graphs. And so once you're done with this, the next one is another model that students can be comfortable with, and this here is computation. You can go on their smartphones, and some of them they're looking at their weather forecast. There are many options. You can see some cool visuals on how each day you have cloud and the sun, versus you have rain with thunder. But that is not the one we're looking at. There are some that has the radar, and the radar has the different colors that represents whether you're going to have a lot of rain or you have light rain or you just have clear clouds. And that is one way of being able to see a simulation that is generated by a computer that represents a complex complex system. And another example would be the ozone layer. You can see the different colors from the year 1970 to currently, how over time the ozone layer that was depleted is somehow trying to get back to how it was before, but still out that needs to be a huge caution as we human beings in terms of how much we are our activities are impacting the ozone layer is really something that scientists are currently ongoingly taking data from and making us aware of the current state of our ozone layer that protects our earth from harmful radiation from the sun. So that is something to be aware of when it comes to computation. Another one here is the fourth one of the model that students should be comfortable with, and this here is called representation. And you're like wondering what is this all about? Essentially, this is where combination of symbols and shapes they come together for you to have an idea on how a particular device or a particular system operates. Like for example, in physics, you guys are exposed to freedom body diagram where you have a ball and you have a particular arrow and then you have angles in there. All that is going to be a representation of explaining the direction and the velocity by which a particular ball with a mass is undergoing when it's going to be colliding maybe with something else with either the same or opposite direction at different angles. And so that is one way of showing this particular representation. Another way you can do this is through circuits where you have the key, you have the energy source, we call it battery, we got the light symbol, and we have the particular shape here which looks more like a rectangle or a square, and this here is the wire that's connecting all of them together for this to be a closed circle or circuit or a system. So this here is how a representation model looks like when students look at their textbook. That is, for example, an example of this. Another one can be different ways by which you can show a particular internal force, like for example tension, torsion, and all that stuff. So that is pretty interesting for them to be aware of when they're looking at their science books or on the internet. The last one here, the last model we're going to look at is called describing. This essentially means using words and sentences in combination with images. These images can be real, can be artistic drawings, like for example NASA sometimes where they try to draw or to get an image of something that they don't really have a clear visual of. They have an artistic illustration label at the bottom of a particular exoplanet or sometimes a black hole. And so that is one way of showing or describing a particular system. Another one can be the model of an atom, the Bohr model of an atom, which is more of an orbital shape or design. Another one that you all are familiar with is the shape of our orbit. People will think that it is a circular orbit, but due to Kepler's Kepler's, we actually can say that it is not circular, it is elliptic. Another one can be, in this case, when we look at our illustration of space-time, is more of a curve, and this curve and bend due to heavy mass. You can see some representation of it that looks like this, and so that is something to be aware of when it comes to describing model. And the goal of this model here is to get the basic idea of a particular system, and this can then be tested on either using mathematics or experiments to prove that it is correct or wrong. Side note, this model of an atom is not really accurate. there's a better model out there due to the new field of science which is known as the quantum. Physicists or chemists will be like battling which one is which, but I'm not going to go into that. And there are other things out there that maybe right or wrong, depending on what experiments will get us to believe which is correct or not. So those are the 5 models that students should be comfortable with when they open their textbook or on the internet. Now, the final one is applications of this particular scientific model. And the applications, they come in 3 ways. One is what using or being able to develop an hypothesis. So if you want to have a particular general idea, have a visual either in these 5 manners to present your idea to support your thinking, your prediction about a particular system on how it operates or it should operate. And then you can use that imagery in this particular model to develop experiments, and this experiment can have a model in the form of a flowchart that tells you what to use, what particular restrictions that you need or materials that is needed, how are the materials arranged in a particular manner, you know, how the time scale on how this is going to be run, what are possible external factors that may contribute to your results, and how can you avoid or eliminate or prevent those external factors from influencing your data. And those are the things that you should be aware of when it comes to developing a model that represents your experiment. And finally, is this particular combination, an application of a model will be how other people can replicate your design of your scientific model, and maybe a couple of tweaks or improvements that will make your model to stand the test of time or move on to future ideas down the road. So overall, I hope you found this really informative in terms of how students can really think about how scientific model can improve their thinking and curiosity and awareness about a couple of things that they see either on a textbook, on the internet, or maybe they want to develop one themselves. So please drop down in the comment section and let me know your thoughts about your experiences as a student, as a teacher. Do you think that some illustrations are not really accurate, or do you think some of them really improved your understanding of different concepts? Drop down into the comment section and let me know your thoughts. All the same, thanks for following me through this. See you on the next one. Stay smart as always and believe in yourselves.